we've talked a little bit about surface area and what surface area means. Now we're going to, and we did it with prisms, now we're going to find surface area of cylinders. So our learning target now is I can construct nets of cylinders, and I can use nets to compute surface area of cylinders. So when we're talking about, earlier we talked about prisms, rectangular prisms specifically, and we said that it was a rectangular prism because it had two bases that were parallel, and they were in the shape of rectangles. Now we have a cylinder, which is another kind of, it's similar to a prism because it has two parallel bases, and the base shape is a circle. It has two of them. And so the area formula for a circle is pi r squared, if you remember that from previous notes. There's two of those again. And then we have, on top of the two cylindrical bases, so I have a vitamin container here. I've got two bases, a circle here, a circle here. And then the lateral surface area is where this label is right now. So where the vitamin label is right now is where the lateral surface area of that shape is. And so that's what we call the lateral surface area. If I were to cut this label right here, make a straight cut and roll it and lay it out flat, it would become a rectangle. So the lateral surface area, or the side of a cylinder, the curved part, if we lay it flat, the two-dimensional shape is a rectangle. The area formula for a rectangle is length times width. And in this case, a cylinder, the lateral surface area is going to be the height of the container, and the length of it, so I would call that the width probably. The length of this, or the height, whatever you want to call it, the length of this from here to here is what do we call the outer edge of a circle? Well, that's circumference. So the dimensions here are the circumference and height, which circumference we know we can write as 2 pi r or pi d, but we're going to use 2 pi r for our circumference. And then times, in this case, it's the height of the cylinder, or length times width, but really that's just the height of the cylinder. So the net of a cylinder is shown below. If we took this vitamin bottle and we took the top and we laid it flat, and we took the bottom and we laid it flat, and then we cut here and we rolled out the lateral surface area flat, this is what it would look like. We would have two circles lying flat with a rectangle in between them. So the net of the cylinder is shown below. Use the net to find the surface area of the cylinder. Give your answer in both forms exact, which means in terms of pi, and rounded to the nearest, in this case, 100th instead of 10th, like we've been doing. So this first one, we've got a circle. We know the area of a circle is pi r squared. In this case, that's 6. So pi times 6 squared is equal to 36 pi. That's the area for this circle right here. We also know that when we have a cylinder, one circle base is the exact same as the other. They are the exact same. That's what makes it a cylinder. They have two parallel and identical bases, and so this circle down here, the area of it is also 36 pi. And then we've got the height of this, they're saying, is 14.8 meters. And then our lateral surface area, again, is height times this length right here is our circumference, which we find the circumference of this circle by doing 2 pi r, or 2 times pi times 6, which is equal to 12 pi. So the area of the rectangle then is 12 times 14.8 times pi. And if we just want it in terms of pi first, we're going to multiply our whole numbers. 12 times 14.8. And when I do that, I get 177 6/10 pi. Don't forget to add that pi in. Sometimes it's easy to think, oh, I multiplied two numbers for length times width, but we've got 12 pi. So all I did here was multiply the two whole numbers first and then add on the pi. So now I've got the area of all three shapes, and in order to find the total surface area, I'm just going to add them together. 36 pi plus 177.6 pi plus 36 pi. Now, notice that I wrote out my work, but then I'm going to use my calculator to do the math here. 36 plus 177.6 plus 36 is equal to 249 6/10 pi. So I just added my whole numbers, and then pi is kind of serving like a variable right now. The exact surface area, or surface area in terms of pi, is 249 6/10 pi. Our units here are meters squared. Remember, surface area, area, square area. We're going to square that unit. If I wanted the estimated answer, I can plug this part into my calculator, 249 6/10 times pi. And when I do that, I get 784.1415263, and it would go on, but they want us to round to the nearest hundredth, so my 4 is in my hundredths place. It looks 1 to the right, the 1 tells me to stay the same, and so my estimated surface area to the nearest hundredth is 784 14/10 meters squared. And that is how we find the surface area of a cylinder. We do two circles, so the formula for this is 2 pi r squared, because we have two circle bases, one circle pi r squared, another one that's the exact same, pi r squared, so that's 2 pi r squared, plus we have the circumference times the height for lateral area, 2 pi r h, gives us our lateral area, so we add the two circle bases plus the lateral area, and this is our formula now for surface area of a cylinder. And note again that you don't necessarily have to memorize this formula, as long as you conceptually can understand and see when we pull this apart and lay out the surface area. We have two circles, and we know the area formula is pi r squared, so two circles is 2 pi r squared. And we added those to the lateral surface area, which was, the dimensions were the circumference times the height. The height goes from one base to another, so that's why when we roll this out, this is the height of that cylinder. And so we do circumference, which we know that formula is 2 pi r, times our height, which is h.